Alright, let's take a look at the last example in today's notes, which is looking at a graph and analyzing it. And this graph is of a linear function. Of course, it is not a continuous linear function. Notice that it is a discrete linear function. It's got a whole bunch of different points plotted there without being connected. Let's read this and see what we can do with it. This graph shows the cost of publishing a school yearbook for college in Winnipeg. The budget for publishing costs $4,200. What is the maximum number of books that can be printed? So this graph shows you the number of yearbooks compared to the cost of printing those yearbooks, right? And you'll notice that there's a whole bunch of different points on there. Our goal is to try and figure out how many books can we get for $4,200. Now, because it's not a connected graph, we can't just look at it right away. So two ways we can do this. Method number one is estimate. Now when you want to estimate, you'll notice that this is a linear function. It's going to make a straight line. However, it's not quite yet connected. You can probably tell me why they can't be connected. That's right, they can't be connected because the number of yearbooks cannot be a fraction, right? We can't have 3/4 of a yearbook. Well, we could, but we're not going to. So as a result, that data cannot be connected. So we're going to go ahead and kind of cheat a little bit. We're going to go ahead and sort of connect it just to kind of estimate where our value is. So I'm going to draw a line over here that kind of connects that. And the only reason I'm doing this is so I can try and extrapolate the value that I'm looking for. So if I go and connect the data, I want to know what is going to be the cost, or what is going to be the number of yearbooks if the cost is $4,200. So if I take a look at the cost of $4,200, this time the cost is given to me. So I'll just take $4,200, which is roughly around here. I'll draw a straight horizontal line all the way up to my graph. And then I'll try and match up and see where this line is going to hit the graph. And I'll try and see where this line sort of matches up with the next value towards the bottom part of the graph. It's a bit tricky to kind of try and position this thing right here. So you end up with something that looks like this, right? So now when you compare this, you'll notice that when the cost is $4,200, the only way that's going to happen is if approximately the number of books you have is a value down here. If you can estimate that, you'll estimate that to be approximately 180 books. Right, so even though there's no data point on my graph corresponding to $4,200, I can kind of extrapolate that data point by just extending this graph, connecting the dots temporarily, so I can see when the y value is 4,200, what is the corresponding x value, because x value tells me the number of yearbooks, and it happens to be 180 books. That's one way of doing it, right? Is it going to be precise? No, it's going to be an estimate. So our method number two is going to be a more precise mathematical algebraic way of doing this. So method number two, and we're going to call this method set up an equation. Alright, to set up our equation, here's what we're going to do. I'm actually going to go ahead and erase this now because I don't need that anymore. If you want to set up an equation, there needs to be some information given to us from the graph. You'll notice that the number of yearbooks, even when the number of yearbooks is 0, we have a point right here. That point is 0,500. So what this is saying is that even when you have 0 yearbooks, the cost is $500. So what this means that the fixed cost is $500. So you're going to pay $500 regardless of how many yearbooks you buy. You have to pay that because even when the yearbooks is zero, you pay $500. The next is I want to see how many yearbooks cost me how much money. Like, what is my rate of change? So I have to calculate the rate of change. Again, if you remember what the rate of change is, rate of change represents change in y values divided by change in x values. So I want to figure out what the rate of change of this graph is. How many books cost how many dollars? So I'll pick any 2 points. Let's say I want to pick these 2 points this time, this one and this one. You'll notice that the number of yearbooks goes up, right? Goes from 100 to 150. In that same span, the y values are increased from 2,500 to 3,500. So plus $1,000. Right? So which means our rate of change is going to be the y value went up by $1,000, and over the same span our x value went up by 50 books, which means the rate of change or the cost price of one book ends up being, what is it going to be? You guess it, $20 per book. So now how can we take this information and convert it into an equation? Well, we're going to say the cost of any number of yearbooks n is going to equal, C of n is going to equal, the fixed cost is going to be our fixed amount. You pay $500 regardless of how many books you buy. Plus, on top of that, you end up paying $20 per book. So, 20 times n plus 500. This ends up being your equation for that function. And we can check that. When n is 0, C of n is 500. When n is 50, C of n is going to be, what is it going to be? 1500, which sort of matches up with that point. And when n is 100, you're going to end up with 2500, which matches up with the second point, and so on and so forth. So now we have an algebraic equation that represents that data. We can now use this to try and figure out how many books are we going to get for $4,200. Right? So now we can check. We can say C of n equals 4,200. What is n going to be? We want to figure out for what value of n is C of n going to be 4,200. I plug that in, just like solving functions a few lessons ago. The y value is 4,200, and you're trying to see what value of n is going to give you that. A little bit of algebra. Subtract 500 from here, subtract 500 from here. You end up with 3,700 equals 20. I forgot the n here, so equals 20n. Lastly, divide both sides by 20. You're going to end up with n equals, what is the n going to be this time? N ends up being 185. Right, so we can say that the maximum number of textbooks that can be printed is going to be 185 textbooks. You'll notice this answer is a bit better than our estimate of about 180 books. So algebraically we get a little bit more accurate answer, though they should be very, very close to each other. Again, keep in mind this one was simply an estimate. However, the estimate and the real answer should be very, very close. Are we okay with that? Okay, we should be. Lastly, we already discussed this kind of at the beginning of the question. Why is the graph above discrete data and not continuous? Again, in case you've forgotten what that means, discrete is points not connected. That's what discrete means. Well, data is discrete and not connected because we cannot have a decimal amount of yearbooks. Right, we cannot have half a yearbook, 3/4 of a yearbook. So the number of yearbooks needs to be a nice round whole number, and that's why we only pick those specific points. Okay, so that brings us to the end of our notes. You now have the ability to go ahead and try your homework and finish it up. Awesome, thank you.